Okay, I'm going to finish these last two problems. So the second degree polynomial about x equals 0 is this. Okay, so for this, you have to know that cosine of x is equal to 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial, so on and so forth. You also have to know that 1 over 1 minus x is equal to 1 plus x squared, so on and so forth. And then you can see that cosine of x times by 1 over 1 minus x is this expression right here. So if I want cosine of x over 1 minus x, that's going to be equal to 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial plus times by 1 plus x squared plus . So we're going to have to FOIL. Now we only want a second degree polynomial, so we just have to keep that in mind. I don't have to go on forever. So 1 times by 1, so that's going to be equal to 1. 1 times by x is going to be equal to x. 1 times by x squared is going to be equal to x squared. And then I'll probably move on to this term right here, and then I'll multiply that through. So negative x squared over 2 factorial times by 1. So that's going to be minus x squared over 2. And then when I multiply this, there we go. When I multiply this here, well, that's actually going to give me a third degree. I don't need a third degree, so I've actually gone as far as I need to. I just need to simplify. So 1 plus x squared minus x squared over 2 is going to be x squared over 2, positive x squared over 2. So the solution is going to be C. And finally, for 9, so let f be the function defined here. Which of the following is the Maclaurin series for f prime? So f of x, which is equal to 1 over 1 minus x, is equal to 1 plus x squared plus all the way to x, all the way to x to the n. And so f prime of x is going to be equal to the derivative of 1 is 0. The derivative of that is going to be 1 plus 2x plus plus n times by x to the n minus 1. So that's what we're going to get right there. And which is equal to the infinite series of n equals 1 to n to the x to the n minus 1. And that is going to line up with B. All right, and there you go. That's the last of the homeworks.